Welcome to Mastering Solutions. So as I've said with a lot of these optics questions, setting it up really is a lot of the battle. Once you get it set up, it's a pretty fun question. I know you probably don't think that about any of these physics problems, but I think it's fun. So down here, we'll say this is the beetle, and the index of refraction that it's in, this polystyrene plastic, is 1.59. So polystyrene plastic. Up here, we have an index of refraction of 1 for air. And so what's happening is this beetle is down here and it's embedded. It's down here and it's embedded in this plastic, right? And so as the light rays come off of this, it's going to come out here and come out here. And now we're going from a high to a low index of refraction. So if we put our normals there for both of these, what's going to happen? Well, it's going to bend away from the normal. So we'll go like this and bend away from the normal. So if we imagine that we're above this, and here's our eyeball, right? There's our eye. And we're looking down at the beetle. To us, where is it going to appear? Our brain says, well, hey, the light rays are coming like this, and it's coming down here. So the image that's going to get formed is actually going to be above the beetle. So this is what we're trying to solve for. We're trying to find out what is the actual distance from the surface down to the beetle. They tell us that it appears this distance right here is the 2 centimeters. The equation that we'll be using to solve for this is given in the book, and it comes from Snell's law. Essentially, they show the derivation in the book, but the equation is the image distance, S prime, is equal to N2 divided by N1 times the object distance, or S. Now, this is what we're actually trying to solve for, right? So we can just divide both sides by N2 over N1. I'll go away. And so now S prime divided by N2 over N1 is equal to S. We can simplify this by divided by the fraction is the same thing as multiplying by the reciprocal. So S is also equal to S prime times N1 over N2. And when we're trying to solve for the object distance here, it can be a little tricky to think about which is the N1 and which is the N2. But the book addresses that and tells us that the N of 1 is what the object is in, and N2 is what the observer is in. So if we apply that here, the object distance is going to be the image distance, which is 2 times 10 to the negative 2 meters. And then we said N1 is the object, so that's going to be the 1.59. And the N2 is what the observer is in, which is going to be N1. So we have 2 times 10 to the negative 2, there we are. And then we're multiplying that by 1.59 over 1, obviously. And so that gives us 0.0318. This is meters. So if we go 1, 2, 3.18, so 3.2. So 3.2 times 10 to the negative 2 meters, or 3.2 centimeters, is how far the beetle is embedded in the plastic, where the image is at 2 centimeters.